So to do this, we are going to call that player projected, and again, we want every row, but we only want certain columns. So we're going to say the player name, the player ID, and then all of the rows that don't have the projection before it. So you see just the points, the minutes, field goals made, etc. And let's save this as the df real. And again, to match up stats, we have to convert the real field goals and free throws and rebounds to the averages and totals. So let's just copy this again. And now in the df real, we have field goal percentage, free throw, rebounds, which again is just taking the division of the makes by the misses and then adding the O-rebs and the D-rebs. And let's get the real columns we want by putting it in another list and passing that list into the data frame, thus dropping any unnecessary columns. So we have our final real columns equals this list. And within this list, what I want are these column values. And data frame real final equals df real with the final real columns list. And we can just look at the head of this data frame. Great, and we have the appropriate columns. Now we can merge the competitor data frame with the real data frame on the player ID. This will make sure everything lines up row-wise so we can split it and run it easily through a root mean squared error function. So here, our competitor final is going to be a PD merge. That's taking our comp merge data frame, our df real final data frame, how it's a left merge, and it's merely on player ID, which is in both now. And then we can sample this. And now it's all across one row with our projections and our real stats. And just like before, we want to just drop any columns if there's no values. And we'll save that into a new data frame. And from this real data frame, we can get that df real and df projection by slicing the data frame columns with the column names using the location. We'll save these into the new data frames and run it through our root mean squared error function. So our df real is now taking our competitor projection data frame, all the rows, and then the real columns. And our df projection is taking our competitor projection with the location, all the rows, but the projected columns. Great, and we can run this. And again, if we run it through our root mean squared error, which I believe we're going to need to import again, this will be 97.4% confident in the projections. That's a pretty good job for the Fantasy Pro guys. So now let's see how we compare. And to do that, we're going to match up against our model for the same stat columns. So we already have our projected stats and real stats in the two data frames, so we can take the df projected final and the df real final. Let's run a sample for each to remember what we're working with. So that was our projection sample, which was the df projection final. And let's run our real final sample. Great, and now we can merge these on the player ID to get our new master data frame. So our model final is going to be a PD merge on the df projection final, the df real final, how it's a left join, on is just the player ID. And again, let's just look at the head of this. First 5 rows. And since we can just slice the data I will copy paste, but this time replacing it with the correct row names for our model, which have the normal stat column names and the projected ones. And one quick thing, we're just going to fill all the nas with 0 in case we run into any issues. When I was running through this, I got an error saying divided by 0 was a failure, so let's fill it with 0 to prevent this from happening. And then we can run it through our root mean squared error calculation, and we get 97.88 confidence, which is just higher than the Fantasy Pro guys, so it looks like we barely edged them out. Obviously, this is a pretty crude measurement, but a good overview of what's possible.